In this tutorial, we will solve a problem related to heat conduction in a rectangular slab. This problem is taken from a book of Heat and Mass Transfer, 5th edition, written by Yunus A Cengel. This is the problem definition. This is the size of the slab. This is the thermal conductivity of the wall. 0.9 watt per meter Kelvin or 0.9 watt per meter centigrade. Both units are equal. So sometime we might be using watt per meter Kelvin or watt per meter centigrade. This is the temperature on one side of the wall, and this is the temperature on other side of the wall. So we are just considering the conduction phenomena in this example. But in the coming problem, we will be considering convection phenomena as well. This is a theoretical solution. This is the heat loss through this wall, 630 watt. So in this example, we will be comparing our theoretical result with our analysis result. This is a result from ANSYS. This is a result that comes from these theoretical calculations. First, we select steady state thermal, and we add a material in engineering data, and the thermal conductivity of the material is 0.9 watt per meter Kelvin or 0.9 watt per meter centigrade. As you can see, both units are equal. And now we construct a geometry in a design modular. These are the dimensions of the geometry: 3 by 5 by 0.3 meter. We select XY plane and we select the units. We are working in meters, and go in sketching and make a rectangle of a size of 3 by 5. 3 meter by 5. So let's make a rectangle. Now here we can dimension the rectangles of the sizes which are given in the problem. So the horizontal dimension is 5 meter and the vertical dimension is 3 meter. Now you can zoom in. Now we are going to extrude it, and the thickness of the geometry is 0.3 meter as given in the problem. You can see on the top right of the screen. And now we are going to generate the geometry, and this is the isometric view of the geometry. Now open the geometry in the model. Here we apply the material, meshing and the boundary conditions. It will take some time. first we will select the unit. It is on top and on the bottom right corner, so you can select the property units you are interested to work in, and here we will apply the material. Now we generate the mesh. Now let's apply the conditions which are given. On one side of the wall the temperature is 16 degrees Celsius, and on the other side of the wall it is 2 degrees Celsius. So first we select the appropriate face. On this face the temperature is 16 degrees Celsius. Now rotate it, and this is the second boundary condition. Select this face, and here the temperature is 2 degrees Celsius. In the solution phase, we select the temperature and we solve it. Here you can see the variation of the temperature along the thickness of the slab, rectangular slab. Now we select the reaction probe. You can use either of the temperature in order to determine the heat loss. Now we solve it again, and you can see here this is the heat loss. Now let's compare our result with the theoretical one. You can see that this is the theoretical heat loss, and this is the heat loss that we have just determined, calculated on ANSYS. Thank you very much. In the coming sessions I will upload videos related to structural mechanics, heat transfers, transient analysis, as well as expressor dynamics and more. Thank you very much.